Well, I freely admit it doesn't take much to confuse me, but I've got no customer repairs in, I'm pleased to say. And if you think I'm working on church organs in this weather, it's -1 outside. I'm not, so we'll stay here in the workshop based at home. So, let's hope the 500 watt electric heat is enough for me not to freeze. Well, I'm trying to evaluate something here, and I'm confused as a baby baboon. KR200 from Jesan KT2002 from Jesan. Well, it looks to me the same. Both 2781 sets, and as far as I was always aware, because I've got 2 circuit diagrams here, so why is the other one not off the printer? Oh, is it on side B of one of these? I'll have to go and find what's happened there. So this is the KR200, and the synthesizer is an LC7137. So the KT2002 has a synthesizer which uses the Motorola MC145156 with its 3 crystal business and all that faffing with a marker oscillator. So it's the same radio but with a different synthesizer. So when I come to evaluate this, and it says KR200 on the back, it definitely does. KR2002. Why on earth have we got an MC145156 synthesizer in this one, making it exactly the same radio? And this has come from an amateur radio acquaintance of mine. He says, you know, have this as something to play with. And I thought, well, I'm far too professional to go playing, but why has it had the board drilled out? What's that about? It says on the lid, wrong lid. It says on the lid, VCO pots missing. Well, pots is short for potentiometer. And I can't see any missing potentiometers. We've got the crystals for the mixers. We've got the trimmer capacitors for the mixers. We've got the cores in the coils. Though bizarrely, this one's been drilled out from the bottom. I just don't know. So, I mean, he said to me, this is scrap, you know. But you know what I'm like. We build a lot of sets out of scrap. And this is a set I just bought in at some point, or, you know, in a batch or whatever. It's not one I'd have gone out and bought individually. So it will have come in with a batch. And to be honest, it looks in reasonable condition. So I set out to see what's up with this. And it has a channel 9 switch. How did they achieve that? There must be a diode matrix to do that. Because it's not a set which has got an instant channel 9 switch, because it's a general purpose synthesizer chip. So it's not like it's got an LC7137 in it, even though my circuit diagram says it does. So it looks like we've got different production of the Jesan KR200 that I wasn't previously aware of. I love that core popping out of its coil. So this one with the holes drilled in the PCB doesn't look to be like it causes a problem. I suppose somebody's done this so they can do it from the wrong side. I will just check continuity, because it doesn't leave much track there. Okay, well, it looks to be intact. There should be a link between... Hang on. This link's in the wrong place. That could be the snag. So we've got on the phase lock loop chip 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And it goes to, we've got a burnt out bit of, oh, we've got a cracked track, haven't we, there? So that's a problem. So that's supposed to go to there. So that could be our first snag. This is why you have to have, you know, when they're butchered about like this is where you need another set. We have them when they've had illegal modifications, we end up with this problem. So what I'm going to do, I'm going to clear over that with isopropyl alcohol and Mr. Chippy's toothbrush. I don't expect these sets are any good anyway when you've done them, but it's it's a challenge, isn't it? It's like being a detective. Ring Scotland Yard and find out what's happened. Whitehall 1212. So what I can now do is see whether we've got any. I'm just looking at some of the solder splodgers around here. We can compare with what we should have. And that looks fine, that's linked fine. Those holes shouldn't make any difference. So sort that out later. I don't know if this set works either, do I? And why has it had this scraper along here, whereas that's got that track intact? This hasn't. They're probably both a bag of worms. Right, I think we better power up the better one, because there's a possibility that that track shouldn't be open circuit there. So we need a power lead with the 3 pins. was being thick there and putting it in the wrong way around. Plug that into the test instrument. I think we're going to see whether we can get this one to work. And then we'll look at the scary one as another separate entity. So what does our microphone list say? Jesan. Says it's Cybernet type. Right, I'll pause the video and go and get one. Okay, so we've now got it connected up. It was on PA, so it's now on CB. I'll tell you what, we'll just see if it works in PA mode, because it is beneficial to fault finding if it does. Testing 1 2. Are they concentric, are they? Testing 1 2, testing 1 2. Wallow. 1 2 1 2. Concentric and dirty. Right, that's that solved. So put it as channel 20. Press transmit. It goes into transmit, but there is no transmit. So my first thoughts, as we switch it back off again, is that we seem to have an open circuit cut to track there. So we can put a solder blob across there. Could be picking up an earth another way. Now we are, Mr. Blobby has done his job. So I'm looking at the ammeter, and we've got no change from transmit to receive when going into transmit. So it isn't trying to transmit. We'll go to channel 9, though on a synthesizer I wouldn't make any test difference. We'll go to, oh, that's full power, is it? Still makes no difference. And the cap that's missing is dim. Goes to control panel lights. Right, well, what I'll do, I'll put on the signal generator, receive frequency of 2779125, and we'll see whether it's receiving. So first of all, we'll just turn the squelch down. Sounds like the mic's not plugged in. Acts like the mic's not plugged in. Okay, so it's receiving. Next question, is it supposed to have two banks of lights like that? Or is one supposed to be transmitted and one supposed to be received? I can tell this receiver is a bit screwed up. It gets louder as it goes smaller on signal, but that's 0.3 of a microvolt, so it's certainly receiving fine. So we know the synthesizer is actually running, otherwise we wouldn't be getting receive on channel 20. So the fact there's no transmit should be pretty simple. So if I get my monitor receiver out, is it transmitting a few inches? Testing 1 2 1 2 1 2, and the answer is no, it's not transmitting a few inches. I think what we'll try and do is to set up the 10.24. And for that, I need the circuit diagram, not that one. So with the right circuit diagram now in front of me, let's just zoom in on that. Make sure we've got the right bit showing on the screen. No. There. So on this version we've got the MC145156, is it? So we've got the 10.24 crystal between pins 3 and 4. On the version I was expecting was the LC7137. In which case the crystal's between pin 11 and 12. So we'll disregard that and we'll monitor pins 3 and 4. So all I need is a BNC lead into my frequency counter. Okay, so we've got this oscilloscope connected up to it. The Multicomp MP720015, and we've got 10.2393. Now crystals drop with age, as I keep saying, so that's hardly surprising. I'm not going to do the receive one at this point. I'm trying to get the transmit to work, so I'm just trying to find the trimming tool as well. Okay, trimming tool on the dog shelf. So we'll adjust that to see whether we can get so the highest we can get is 10.2398. So we're going to have to play jiggery pokery like we did on the JWRM2, which theoretically means the receiver will be slightly lopsided, but in reality it's so close it really doesn't matter. So that's that done. So now we need to identify which is the transmit one and which is the receive one, because I haven't got the foggiest. So once again I'll take the oscilloscope off and we're now going to transmit. I'll see if any of these are triggered. And the answer is I can't tell. So we'll have to look at the circuit as to what's going on here. You know, the trouble is, the photocopies of these circuits out of instruction books and then scanned, the clarity just isn't there to read what's going on. and I don't see enough of them to remember which one's which. Well, seeing as it's receiving, let's upset the receive. So whichever of these we upset the receive with, now that's upsetting the receive. And that's not. So that's our transmit one. So CT, so Crystal 2 is the transmit one. So that's that one. Crystal 2. So let's see where that oscillator goes. It goes into that chip, and the first place it goes out of there is 106, coil 106. So which is coil 106? It is there. That's coil 106. So what I think we need to do, we have a crystal oscillator here. So I think we need to monitor what's on diode 21. And of course it's going to be, oh, it's there luckily, and the pin is such that the one we want is the one that's showing. We are lucky there. So diode 21 in transmit. Just see if we need an earth. So we've got 16 point something or other. And we can alter that. So let's monitor pin 8 of this IC. And I wonder if there's a convenient capacitor leg to put it onto. Not quite, but we might be able to monitor it at R72. R72 and L8. 17.0975, it's going to transmit. I'm just wondering if this IC is not getting any power, or whether this IC is faulty. Looks like it gets the power to 8. It's 9 I should have been monitoring. So resistor 71 should be the power feed. It's probably easier to look at this one. It's probably easier to monitor the voltage. Yeah, I know that oscilloscope's a multimeter as well, but you know, it's a faff to take it from one mode to another. Let's look at pin 8. So I'd expect it only probably powers up in transmit. So let's see where we are. 1, 2, 3, 4, 5, 6, 7. Could be that one. Going to transmit. 2.7 volts, that's never right. Unless it's that one. Yeah, that looks like it's the power. So pin 9's the output. So we'll go back to the oscilloscope. Pin 9. Press transmit. You know what, I'm going to change this chip. I just haven't got what I'm expecting to be coming out of it. Okay, so moving forwards, I've changed that, and I've also had to pinch the crystal off the other one of these. So the one with the holes in the board, I think is now a donor. So I've changed the chip, but I noticed that the crystal, it had fallen off its legs. Now, did I knock it off its legs, or what? I don't know. So the IC is being changed, and I'm about to change the crystal for the one off the other chassis. And that just proved it does still work. So at the end of the day, if I've got to start ordering crystals at 30 quid each, the set's barely worth that. So if at least if we can get one going out of the two, it's not like they're really sought after valuable sets. So now we'll never know whether it was the chip or the IC, or whether it was the crystal if it now bursts into life. Right, I'll switch the power supply back on. I'm not quite sure why I've suddenly got a power lead around my ankles. Okay, so we're back on. Into transmit, and still nothing happening. Let's get the monitor receiver back. Ah, now we've got transmit into our monitor receiver. So that's interesting, isn't it? Good. 1, 2, 1. Okay, so that's a major step forward. We may not still have transmit, but that's happening. So are we in 4-watt mode? We are. I think what we will do is we'll just see if I can see it on the spectrum analyzer now. We might be far enough advanced to see it. So I'll put that on the spectrum analyzer. Let's put in the frequency 2779125 megs. So I'll now put that in the general direction, just a loose crocodile clip. Yeah, look, can you see, if we go around where that IC I've changed, we can see the 27 meg signal. So where should we put this? So I think we need to just see where the first... It's a possibility that there's no power to the transmit early stages. Whatever, I say the crystal fell apart, the IC, I don't know. So we're adjusting that first coil. So we know we've got the 27 megs in this vicinity, and we know it's adjusting. But it doesn't seem to be going any further. We're not getting any drive any further. So we need to monitor it really, I think. See if I can see what capacity we can. Probably looks like 98, 99, or the base of transistor 18. And these are sets with no layouts. It's never easy. So we are just here. You've got the IC I've changed. We've got a signal here, but are we getting as far as this transistor? Because surely if we were, then we would be getting drive. Or does the PA not have any drive? You know, might also be something to look at. This is where we get the Russian diode probe out. I wish it had a sharper point on it than this, but it doesn't. So I'm going to look at the bottom of this transistor, which incidentally is being changed. So we've got, it looks like we've got RF there. That's on the driver transistor. You'd expect more than that. See, we've got a lot there. So it's certainly doing its RF stuff. So I think we'll just look at the voltage on that transistor and make sure we've got rail voltage, which will be on all the time. Well, I would have thought so. Yeah, so we've got 11 volts there. Now it could be that that transistor is short circuit and is robbing the radio of any power. So I think we'll whip that out, because it's clear to me that it's had that transistor changed, the pre-driver, and it's had the driver transistor itself changed, and at some time it's had the PA transistor changed. So I think we've had Mr. Bad SWR at some point, and it failing again in inverted commas could have been the last straw. And I suppose it ultimately it could have shorted the output of that IC, couldn't it? Right. Pause the video. So the driver transistor here, if we can just see that, hopefully. Yeah. I just need my well, we're going to rustle the microphones. My little tester. Move the camera across a fraction. There we go. Faulty. Well, I'll tell you what, since we're using this for parts, we may as well pinch the driver transistor out of this one. And this is quite clearly the original. So we'll test the donor part. Uh-oh. Have we got a faulty one as well? No, it's the way I got the leads on. Right, we'll see what happens now. Can find where I put the mic. Let's follow the lead. Switch on. Press transmit. And nothing. Now we can be back to these not being aligned right. And so once again I'll look at the spectrum analyzer. So we're not getting over there. So we're still not getting really any further than where we were. Let's see whether we can just... See, these transistors can be duff as well. I think that's what we're going to go for. So far we know we've brought back this crystal in operation, but whether it was the IC, whether it was the crystal, whether it was both, I couldn't pin down. Those ICs are pence, those crystals are a lot of money, but like I say, as you know, we recovered it from the other set. So I'm going to unsolder that transistor and we'll test that. Right, so change the driver transistor, the pre-driver transistor, and I couldn't test it because one of the legs fell off in unsoldering it. So I've pinched one off that other set, and we can now go over to the fact we've got transmit, as you can see on the spectrum analyzer. So we'll go over to the normal power meter. No, we won't. Yes, we will. And 3.8 watts. Just like that. So we'll go through the tuning. And then I reckon it's lunchtime. Oh my goodness. I was on the other scale. That's low power, that's high power. Oh, he's had the screwdriver expert to untweak it. That's 3 watts. And he's had the coil stretcher. We'll have to look at that with the spectrum analyzer. So that's our first one, brings us up to 3 watts. 3 watts. 3 watts. 3.5 watts. We'll just check back on that one. 3.6 watts. But that one looks like it's had the stretcher on it, so we will look at that. In fact, I can see it on the screen right now. Just look at the other one to see how it's yeah, it's rests horizontally. So push that down so it rests horizontally like the other set. And that has reduced the power to 3.1 watts. So let's just, I'm looking at this now with the spectrum analyzer, which we'll go over to. I'll just move the marker across, because I've got a nasty spurious on. Let's see whether we can sort it with one of those. So that's the best position as a compromise between power and spurious. I'll just tidy these up as best I can. So just lower the gain, and all we've got's the fundamentals. So that's acceptable now. So we'll just now look back at power. So it's 3.4 watts. Just very carefully make sure we're on peak there. So yeah, it's 3.5 watts. Let's look how many Zetagi watts it is, because you all want to know that. Four and a half Zetagi watts. So, but at least it's nearly all where it should be. So, we've replaced the crystal, we've replaced the chip. You know, that was short circuit. That was no doubt faulty because I replaced it and it works. The IC could have been shorted out. The crystal was falling off the board, so it could have been either or both of those. And there. So we'll just do the frequency, which is what we were trying to look at in the first place, which is what that trimmer's for. So I'll better switch back to internal. So we want 2779125. Now, I've set that crystal for maximum output, and it's not far off. There we go, 27. I'll just give it another twaggle. There you are, 79125 on transmit. So we've got 10.24 as close as we can. We've got 2779125 on transmit, spot on. So now when we come to receive, then we'll set it up with the marker oscillator. We're getting somewhere. Let's look at transmitted audio. Wallow, what a bit loud. I made some notes. Deviations RV5. You know, instead of poking my head over it, it's easier to look at this other one. Four. 3, 1, 6, 7. It's got a built-in SWR meter. To be honest, I'd expect it to be this one here. Yeah, it is. It's 5. So get the little oscillator out. Yeah, it's over the top. Interesting. I'm not getting any adjustment. Don't tell me it is that one. It is. So I've no idea what I've gone and upset. Wallow. It's actually a bit low, that. It didn't set up how we expected. Let's try that. Wallow. That's spot on. And we'll just see what it sounds like into our monitor receiver. Testing 1 2, testing 1 2 3. Good. So there we are. It's another task done. Now it's got high-low power, and it should be 0.4 of a watt, and it's 0.5 of a watt. As far as I'm concerned, that isn't adjustable. I couldn't see anything on the circuit diagram. I'm going to have to rethink what that is though. So the only thing left now is the RF meter, which I believe to be RV4. See, I just can't trust the circuit, can I? I would expect it to be one of those two. One of those is the SWR meter, the other one's going to be the meter on the front. So 4 watts should be all lit. So, no, it should be 4 lit. And on low power, I expect it's 1 that lights. It is. So we've got that right. 1, 4. So it's RV whatever that is. So that's going to be the SWR meter, and we may as well do that now because we're in transmit. So select SWR, however you do that. Oh yeah, there we go. So of course it's 1 to 1. So SWR cal's the inner. There we go. And SWR should be nothing. So that other preset, which I haven't touched, I'm going to have to put that on the aerial later because the adjustment is such that it's not giving me any lights with it being a 0 perfect SWR. So we'll come back to the SWR preset. Good, well, we've done all the hard work, so it's just really setting the receiver up, which I know is off because it sounds it, and we'll be doing the Crystal Oscillator, which is this one, with the marker oscillator. Bit long-winded this set. So once again I've got the Field Tech little signal generator out, which I'm going to use as a marker oscillator. I'll put picture in picture on. So we've got that feeding into the frequency counter on the test set, and as you can see it's 10.695, and then we'll just disconnect that and switch to receive, which as you can see when we go to internal is 27.79.125 ish. So we should be generating a musical note. I'll take the tone off. There we go. Now, I don't know whether you can hear that because the volume's low for some reason on this radio. It's like something's not earthed. Anyway, let's hope you can hear it. And I will now alter the receive crystal mixer, and so with the 27.79.125 on the signal generator here, and with the 10.695 from here, actually we can hear it better if I hold that. See whether we can null the musical note. Here we go. There we are, done. So 10.695 from here, 2779125. The only error can now be the crystals. We've corrected that, and now we're spot on frequency. So I'll turn this off once again. So now we're on frequency, we can start tuning up the radio. So we'll put the signal generator back on. So I have no idea why this is low volume. Certainly something amiss somewhere. Anyway, we'll see whether we can tune it as it is. So what we want is 100 microvolts. No, that's not acceptable. It's too distorted. So I wonder if we're... I don't know what's happening. Let's see whether we can see what it's which one of these is positive. Black one is. So I think we're kind of just incompatible, because the black one is audio hot. So I'll tell you what, we're going to crocodile clip lead it to, so it's not low volume at all, it's just that it's opposite way around for my test gear. It's kind of looks like it's positive earth or something. There we go. Right, so now we'll look at the oscilloscope. And that's horrible. So I think the detector looks to be like T7. If I get my other chassis out. I just can't trust, if I can read it, I can't trust what I'm reading. I think we're going to be talking about this coil here. I am. We can now reduce the amplitude. So there we are at maximum. I'll just do these IF ones. We'll go to the synod meter. I'll go through the front end. So now we've got that absolutely sinusoidal as it should be. Remember how jagged it was when we started off. Yeah, I think we're there. Good. So we'll now go to S9. See if we can. Looks like RV1 is the S meter. So we should have S9. RV1. But it isn't, you know. So is it that one we thought was deviation? No. I hate having to guess all these. Oh, we're not in S meter mode, are we? So we were right. So that's where S9 needs to be. Yep. I've given it four bars. I'll just see if low power is adjustable. So I think that is low power. No. Well, that's not going to be, is it? No, I really don't know. Wonder if that's to do with delta tune. That's something we'll come back to. So I'm hoping that's going to be there for squelch. So we'll do that right now. So I'll set the squelch to full. Set the signal generator to 100 microvolts. And it actually comes in where we want it to. But where, just to prove that which preset it is, see if it's that one. No. See if it's that one. No. So according to my notes, squelch looks to be RV2. It's that one. Have I gone and upset that one? I can't remember now. Yes, I have. That was the meter. So meter, squelch. So that's exactly where I want it to be. So turn the radio down, turn the signal generator off. And turn the squelch down. Put the signal generator back on. See where it comes in. It's not that sensitive, it's about 2.8 microvolts. Let's just try that a test again. So I'll reset the squelch. Really, oh, I've got noise blank on, that might make a difference. Try again. Yeah, it's not overly sensitive. That's the best we can achieve. Could do with cleaning some of these presets, to be honest. Some of the main controls, sorry. So we've got mystery control there. No, that's squelch. We've got mystery control there, and it's RV5, which I thought was deviation. Okay, well, that's one we're not sure about. Wallow. So we've got that, we've got transmit, we've got .6 watts, now it's cooled down. So we'll check the SWR. Try and set that. So what we'll do, we'll plug in the aerial, and this time we'll use the target meter as a calibration aid. Hopefully it's set well enough as a SWR meter. So there we are, into a dummy load. So we'll take the dummy load out and replace that with our aerial. It's about 1.7, 1.8, I remember rightly. So we're on channel 20, let's have a look. You know, it's about 1.8, so it's lying on the SWR as well. So it's about 1.4 according to this. So if we set this SWR meter to read 1.4, 1.5, somewhere around there, let's see where we are. So into Calibrate. There we are, Calibrate, SWR. So we've got nothing reading and we need something to read. No, I can't get it to read anything. Let's cheat and put the Calibrate right up. Ah. Well, it does work, but it's I think you'd have to, just for a second, I'll unplug the aerial and then key up. Yeah, we've got a full set of bars, so it does work, but it's not something you'd want to really trust, except to show that you have a bad aerial, a really bad aerial. Okay, we'll put our dummy load back in. So the only thing left is that preset to do with dummy load. Start again. Is that preset to do with the Delta tune? So I'll use the cyanide meter and turn the squelch down. See if it comes. Oh, I'll put the meter onto the screen. So at the moment we've got about 4.5 dB. So let's alter the delta tune. I can't honestly say I can hear that altering. So we'll use this preset. Now I'm stumped with that. I'm just put it to halfway position. Nope. Don't know. Right, I'll put it on the aerial and we'll put the lids on and we'll see whether we can hear anybody on it. I decided to put the case through the dishwasher and I'm just taking the speaker out of the lid. We'll just wait for that to kind of finish. Let's do the cyanide. It doesn't look that sensitive, to be honest. So 20 dB. Oh, are we going on and off now, are we? $20 dB, 12 dB and 10 dB cyanide. Let's just look at what we can get. Right, so we'll start with that 20 figure. Not all radios can achieve this, and we're always between scales. It looks like a 3.1 to me. Look on the other scale. Yeah, 3.1 microvolts. Now the important ones. 12 dB. 0.79 microvolts, and 10 dB, 0.59 microvolts. So when we did the squelch, it wasn't that sensitive, so we'll see how that goes around Scratchy Corner. So all that remains to do is for the dishwasher to finish and for me to put the radio back together, and then we'll just do a little flick round on the air like we do. Okay, so to conclude, we've got it on an aerial now. The knobs aren't missing, the dishwasher gobbled them. You probably saw on the servicing video I inadvertently did the S meter, but I did redo the S meter, so it wasn't really as big a cock up as you might think. Right, here, let's have a look. Nana Roger. I'm not a lover of concentric controls. Okay, well, so there's somebody out there. So you've got on-off volume and squelch, mic gain, RF gain, SWR calibration and delta tune, and then here we've got the SWR calibrate and all that, which I did go through. Got dimmer for the screen. Let's see if we can turn that light off. You might just see it. It does all light up the control panel. So there you have it, the Jesan KT2002. A lot of work, and of course it's not a very good radio at the end of the day. It's very insensitive squelch. I've managed to get 3.6 watts out of it. But to be honest, as soon as it starts warming up, it's 3.1 watt. So don't know how we're going to do over Scratchy Corner, and I think the sensitivity of that squelch will be such that we struggle. So thank you for watching. Very long-winded, the Jesan.